Hello everyone, welcome to my channel Ali Sir Chemistry Class for All. Today I am going to discuss about organic chemistry, the basic organic chemistry, which is helpful for generally honors students who are preparing for NEET, JAM, etc. Today's class will be totally in English or little bit in Hindi version. So it is applicable for all the students from all over the India and the world. That's why I'm decided to make my videos in English. Few times I will use some Hindis or Bengali, which is helpful for Indian students also. So today I am going to discuss first the basic concept of some organic chemistry topics, which is already written in the board. You can see organic chemistry, electron displacement in a molecules. Today's topics will focus mainly on electron displacement in a molecules. Electron displacement. What is mean by electron displacement? Electron displacements mean the movement of electrons from a single bond or a double bond or a conjugated system. That means from one center to another center, the displacement of electron is taking place during a chemical reactions. That is the main things in a chemical reactions. Chemical reaction is nothing but the displacement of electron from one center to another center. So to know the chemical reactions in details, we first have to understood how the displacement of how the displacements of electron taking place, and what is the reason behind it, what are the process and their applications. So you can see there are four main reasons, main points which are helpful for explanation how the electron displacement is taking place in a molecule. First one is inductive effect, second one is electromagnetic effect, third one is resonance effect, and fourth is hyperconjugative effect. From these four effect, the first one, that is inductive effect, and the fourth one and the third and fourth one are also very important. We'll mainly focus on three effects, that is inductive effect, resonance effect, hyperconjugative effect. After that, we'll also focus on electromagnetic effect, which is not so important, but we'll go through that. So students, you can see the heading of the today's class is electron displacement in a molecules. Displacement, when the electron displacement is taking place, the molecules becomes polar, molecules become ionized, molecules becomes reactive, molecules become polarized. So this process have to understood very carefully. So students, listen carefully in this class and concentrate yourself. First of all, I am going to discuss about inductive effect. The first one, inductive effect. How this inductive effect is affected in a molecules to displace the electrons. So what is mean by inductive effect? Let us consider a molecules, a homonuclear diatomic molecules, say H2 or Cl2. If you see, the H2 molecules, in hydrogen molecules, the two electrons, that is one covalent bonds between the two hydrogen atoms, are equally shared by the two hydrogen atoms. That means the two electrons are equally shared. What is the reason behind it? We know both the atoms are same. Here is H and here is H. Both the atoms are same. That means their electronegativity is the same. So the bonding electron will not shift towards any atom. It will remain in between the covalent bonds. So there is no movement of electrons, that is no displacement of electrons. That means we know here the mu is equal to 0. Dipole moments of the molecules become 0. So no charge separation. Similarly for chlorine molecules, here is also chlorine, the same atoms. There is no electronegativity difference. So the dipole moment of this molecule is also 0. But whenever we move from these molecules to another types of molecules, that is heteronuclear diatomic molecule. Heteronuclear diatomic molecules, say HCl, HBr, HI, etc. Think about HCl molecules. HCl molecules, if you see in HCl molecules, chlorine atom is much more electronegative than hydrogen atoms. So the bonding electrons between the hydrogen and chlorine, that is one bond pair, you can see easily here, one is bond pair. The bonding electron shifted towards the chlorine atom because it is more electronegative than hydrogen atoms. So here is a charge separation. That means displacement of electrons are taking place from hydrogen to chlorine. So chlorine becomes, Cl becomes delta negative charge and hydrogen becomes delta positive charge. So the dipole moment of the molecules have some positive values. So to be electron transfer from one center to another center, there must be an electronegativity difference between the two bonded atoms. That is the primary condition for the electron displacement process. It is similar phenomenon like when heat is transferred from one place to another place, one place become hot and another place become cooled. Same things here also happens. The electron displacement is taking place from dense center to more dense center to less dense center. That is electropositive element to electronegative element. We know the electronegative element have the tendency to attract the electron pair towards itself, and electropositive element have the tendency to push the electron to the other atom. This is the basic of inductive effect. So if you consider here, in generally a molecules of types AB, I have written here AB, and let the electronegativity of B is greater than A. So the bonding electrons will be shifted towards B. That means it acquires delta negative charge and A acquires delta positive charge. Which atoms or groups will attract the electron pairs towards themselves? That groups of that atoms is showing inductive effect, which is called minus I effect. And the atoms or group which is repel the electrons or pushing the electrons towards another atom is called plus I effect group. That is, here A is showing plus I effect. The simple things. There is a bond between A and B. We think we consider B is more electronegative than A. That means the bond pair will be shifted more towards B. So B become delta negative and A become delta positive. So the atoms or groups which attract the electron pair towards itself is showing minus I effect, and the atom which repel the electron towards the electronegative atom is showing plus I effect. That is the simple things of inductive effect. That is the easiest way to remember about the inductive effect. So what you have learned here, inductive effect means nothing but the attraction of electron towards itself by the electronegative atoms or group, and in another word we can say it is nothing but the pushing of electron of electropositive atoms or group towards electronegative atoms. So clearly you can see the inductive effect is two types, that is plus I effect and another is minus I effect. So we will discuss which group will show plus I effect and which groups will show minus I effect. You can easily consider that the molecules or groups which have electronegative character, that will show minus I effect, and the elements or groups which have electropositive character will show plus I effect. It is as simple as that. Let us consider some few examples. If you see carbon, there is H and X. Methyl and X is halogens, chlorine, bromine or iodine. Here X group, X means halogens, that is electronegative. It will attract the electron towards itself, and this methyl group is repel the electron towards or pushing the electron towards X atom. So this center become delta negative and carbon center become delta positive. So here X is showing minus I effect and methyl group is showing plus I effect. You can easily determine in a molecules which group will show plus I effect and which group will show minus I effect. So I will give some examples of groups or atoms which is showing plus I effect and the groups or atoms which is showing minus I effect. There is a list, for showing the minus I effect or showing the plus I effect, what should be the basic and primary conditions. First one I am going to discuss what is the criteria. What is the criteria of a group or atoms to show plus I effect? Plus I effect, that means that group or atom should be pushed electrons. So in one word we can say that the molecule must have to more concentrated electron pair or more dense electron around itself. That means electron density will be maximum so that it can repel the electron or it can push the electron towards electronegative atom. So generally in first chance you can see you can say that the atoms or groups which have negative charge means that atoms or group have more electrons on it, so it can repel or donate the electrons. It can push the electron towards electronegative atoms. So first of all, the groups or atoms which have negative charge, they are all showing minus I effect. So you can say O negative, such as COO minus carboxylate, and all alkyl groups CCH3 whole 3, CH CH3 whole 3, sorry, whole 2, CH2 CH3 CH3 DH. This is the basic order, the primary order of the groups or atoms which are showing plus I effect. You can see that here O minus is negatively charged. That means electron density is very much here, and COO minus is also negatively charged anions. So they are showing plus I effect because they have the more electron density around this group or around this atom. And alkyl groups, that is tertiary butyl, which have the tendency to pull push the electrons. There is isopropyl groups. This is also have plus I effect. Then ethyl group and methyl group, then deuterium and hydrogen. So with increasing number of methyl group, the plus I effect is also increases. You can see there is only one. This is methyl group. This is ethyl group where is one methyl group is present. The isopropyl where two methyl group is present. In tertiary butyl here 3 methyl group is present. That's why the tertiary butyl have the more plus I effect. So whatever you have learned here, I am just summarizing that the groups which have electron densities more on the atoms or the groups, they are showing plus I effect. So in generally you can say that anions are showing always plus I effect, and including anions, here we have C, alkyl group is also showing plus I effect. And whereas alkyl group concerned, the tertiary butyl groups is showing more plus I effect compared to secondary, compared to primary, and compared to methyl group. Next we are moving to the groups which are showing minus I effect. Minus I effect. Minus I effect means they are withdrawing electron towards itself. So which molecules or which groups or which atoms will withdraw the electron towards itself? You can say the atoms or groups which have less electron density or which are more electronegative, that atoms or groups will attract the electron pairs towards itself. So in first you can say that as in plus I effect, anions are showing plus I effect because they have the more electron density. So in case of minus I effect, you can say that cations will show plus I effect because they have less electron density. That's why they are positively charged. So you can write a series of examples of groups which are showing plus I effect. For examples, in R3, you can see there is positive charge. That means it has less electron density here. So it can withdraw the electron towards itself. That means it will show minus I effect. SR2 plus. Here you can see plus. This will show plus I, minus I effect. NH3 plus. It will also show minus effect. Here is plus is present. nitro group NO2. Here, if you write down the nitro group, you can see it will look like this type. Here, nitrogen center is positively charged, so it will attract the electron towards itself. That means it will show minus I effect. Then sulfonic acid SO3H, here electronegative element is present, sulfur is present, sulfonic acid, cyanide, fluoride, carboxylate, chlorine, bromine, iodine, OR, OH, NR2, NHR, NH2, C111CH, C6H5, CH11CH2H. So you can easily explain why these types of groups or atoms showing plus I effect. In first group, you can see nitrogen containing a positive charge. It will attract the electron towards itself. That means it is showing the electronegative property. So this will show minus I effect. Similarly for the second one, similarly for the third one, and for the nitro group, there is a positive charge on nitrogen atom. It will show minus I effect because it will attract the electron pair. A sulfonic acid group, cyanide. In cyanide, you can interestingly see that in cyanide, I can show you cyanide, CN. Here, hybridization of this carbon is sp, and nitrogen is also electronegative. This nitrogen is electronegative element. So this combining effect, this hybridization means sp means percentage of S character is very much high, which is 50%. Maximum S character. We know with increasing the S character, the electronegativity is increases because S electrons are more closer to the nucleus and they will attract the nucleus very much effectively by another types of electrons compared to another types of electrons. So here S percentage is 50%, and nitrogen is also electronegative element. So this makes this CN group is much more electronegative. That means it will show minus I effect strongly. Then chlorine, chlorine is electronegative element, carboxylic acid, chlorine, bromine, iodine, OR, oxygen, NR2, NHR, all these types of molecules are electronegative atoms. Here C111CH, this carbon is sp hybridized, so this is also showing minus I effect. In phenyl, if you see in phenyl is also show minus effect because this carbon is sp2 carbon. sp2 carbon means percentage of S character is 33.3%. So it has some electronegative character also compared to sp3 carbon. And you see CH, the alkene is also so minus I effect because here you can see carbon is sp2 hybridized. That means CH11CH2 carbon has 33.33% S character. So compared to sp3 hybridized alkane, it has more S character. So it will show minus I effect. I think this is clear for all of you why these groups are showing minus I effect and which is more stronger, which is less stronger. That will you can easily understood by considering their tendency to attract the electron pairs towards themselves. Let us consider a molecule, a chain molecule. Say CH3, CH2, 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 Cl. What is this molecule? 1, 2, 3, 4. 1 chlorobutane. In 1 chlorobutane, if you see, there is an alkyl chain, which is butyl chain, and 1 chlorine atoms. You know, chlorine atoms has minus I effect. So it will attract the electron towards itself. That means it becomes delta negative charge. And this center, which is directly attached to the chlorine atom, will acquire a positive charge, which is, you say, delta 1 plus. But the effect of chlorine atom will be lesser when you move from 1 to 2, and will be also less from 2 to 3 and simultaneously. So we can write it double delta plus 1 1. You can write it delta 3 plus, you can write here delta 4 plus. So gradually when you move from a group to the chain systems, when the distance is increases, the effect of the electron withdrawing effect of chlorine will be reduced. That means it is maximum in carbon number 1, then will decreases gradually from 2 to 3 to 4. So what we conclude from here, that with increasing distance, the effect of inductive effect will reduces. So when you move from one center to another center, the distance from the electronegative center or delta negative center is increases, the effect is reduces. There is a delta 1 plus, and delta 2 plus, delta 3 plus, delta 4 plus. That means here we can write delta 1 plus is greater than, delta 2 plus is greater than, delta 3 plus is greater than, delta 4 plus. And which is equal to, if you summarize here, this is a neutral molecule. So you can say that this delta negative charge will be equal to delta 1 plus, delta 2 plus, delta 3 plus, delta 4, delta 3 plus, delta 4 plus. This charge is equal to this positive charge. That's why the molecule is neutral. So whatever we conclude here, we can say in one line, with increasing distance, the effect of both plus I and minus I effect is reduces, and it is effective up to 3 carbon chain atom. After 3, it effects will reduces very much. That means always. That means almost negligible. Now we can move our concentration to the another part of this inductive effect. What is the cause behind this? What is the cause behind this, and what is the influence of this effect in the molecules, and how the electron displacement taking place? That part I will discuss here. First of all, I will discuss characteristics of inductive effect. Characteristics of inductive effect. What are the characteristics of inductive? Whatever you have learned, you can summarize this. How the electronegative effect on inductive effect. There is, we know that alkane is less polar among the hydrocarbon. How you can explain it? In alkane, you see, for example, CH4 molecules, there is, or C2H6 molecules, there is one carbon and hydrogen bond. But here, one CC bond is also present and CH bond is also present. You know this bond is non-polar because both the atoms are same CC. But if you consider the carbon and hydrogen bond, here you consider the carbon and hydrogen bond that are also non-polar type, because the electronegativity difference between the carbon and hydrogen is very much low. If you see the literature value, the electronegativity of carbon is 2.5 and hydrogen is almost 2.1. So there is little bit electronegativity difference, whichever you can think, this is almost negligible. So CH bond is non-polar. Second one is, you can say, where the inductive effect will operates. It will affects, whatever you want to say, it will affects only in single bond, that is sigma bond. It is effective only in single bond or sigma bond. Inductive effect is always effective in single bond or sigma bond. Number 3, inductive effect is permanent. It is very much important. This is not a temporary effect. Inductive effect is permanent and irreversible. So, inductive effect is always permanent and irreversible. Different groups cause the different polarity. Different atoms will cause the different polarity. That are the characteristics of inductive effect. Now, we'll go through the most important part of this inductive effect, that is the application part. What are the applications of this inductive effect? How can we explain the different physical and chemical properties of the compound by using this inductive effect? That is the most important part. Whatever we have learned till now, the bottom line is in heteronuclear molecules, the atoms or groups which is more electronegative, that will acquire negatively charged, and another one is acquire positively charged. Here you consider B is more electronegative than A. So which contain delta positive charge, that will show plus I effect, and which contain delta negative charge, that will show minus I effect. That is the bottom lines, whatever we have learned, we have discussed till now in this class. Now we are moving to the application part of inductive effect. That is how the physical and chemical properties of the molecules can be discussed, can be explained with the help of this inductive effect. So we can write here application of inductive effect. you have already run in your class, in previous class, anywhere, whatever you have learned the polarity of the molecules. You have listened or you have learned, you have already known the polarity of the molecule. The polarity of the molecule basically depends on these factors, that is inductive effect. Polarity means there are two dipoles in a molecules. One is delta positive, another is delta negative. So which character of the groups or atoms will create this delta positive and delta negative center in a molecules? That is electronegativity difference of the groups and atoms. That means you can say the inductive effect, that is plus I effect, which is electropositive character of the atoms or groups, and minus I effect, which is electronegative character of the groups or atoms. For example, first one I am going to discuss about the physical property, that is dipole moment. Okay. All of you know, I think all of you know what do you mean by dipole moment. That is two center, one is delta positive and say A, and another center is B, that is delta negative. When there is a electronegativity difference between the two atoms or groups or more groups or atoms, that is the basic things for a molecules to be polar, and the polar molecules mean the molecule have a permanent dipole moment. So you know the dipole moment is expressed in terms of mu is equal to E into L, and this unit is dBi. All of you know this, but how can we explain with the help of this inductive effect? Let us say, for example, cis-2-butene and trans-2-butene. Initially, I will go through the simple examples, and after the class, when this class is over, and when question answer session will become, at that time I will discuss some more typical questions which are effective for competitive exams and a higher study. So first one, I am going to discuss about these two simple molecules, cis-2-butene. All of you know this. Cis means two same groups remains in the same site. This is cis-2-butene, and another one is trans-2-butene. All of you know dipole moment is a vector quantity. So vector quantity means if there is two dipole, there is a vectorial addition, which is the resultant dipole of the molecules. You see, in cis-2-butenes, methyl group is showing plus I effect. So electrons will displaced from methyl center to carbon C double center. In this group, in this side also, the bond electrons of CCH3 bond will move towards move towards C double bond C. So the direction, if you see the direction, this direction and here is these directions. So these are almost same direction, not same, but they are not in opposite direction. When both are in opposite direction and same values, then dipole moment becomes 0. But they're not in opposite direction, they are almost in same direction, they have same group. So here, if you say this is plus x, if this is plus y, so there will be some value, say new value z. So you can get some dipole moment of this molecule, some positive value. But whenever we see in trans molecule, trans-2-butene, the dipole of the CCH3 group towards the C double bond C, and this is towards the C double bond C. But the direction in opposite. If you say this is plus x and this become minus x. So the vectorial addition of this two dipole will be plus x minus x, which is become 0. That's why the trans 2 between has dipole moment equal to 0, whereas cis 2 between have some positive value. So students, you can see how easily you can explain it. This is basically depend on plus I effect. Plus I effect of methyl group. Here two methyl group in plus I effect is showing in almost same direction, but not in opposite direction. So they have some positive values. But in trans 2 butene, the two methyl groups are in opposite to each other. That means their bond angle is almost equal to 180 degree. So if you say the value of this CCH3 dipole is plus x and this is the minus x, then the addition will be 0. That means B becomes 0. So you can explain the dipole moments of the molecules by using this plus I and minus I effect. Now I move to the important property, that is chemical properties of the molecules, which are most important towards all the chemists, all the students. We simply whatever books you have learned, you can say all books are basically focused on chemical properties. Physical properties, there are some examples, little bit, that means boiling point, melting points, and specific density, melting point, boiling point, and their bond angle, something like that. They're the physical properties, but they are also very simple. You can explain it easily. But whenever the terms of chemical properties is whenever the chemical properties is concerned, then we have to consider in different way. For example, you can say that all of you know, I think, I am going to show you examples, that is electrophilic, aromatic electrophilic substitution. The most famous examples you have learned in your class 12s or in your graduations, that whenever benzene is treated with nitric acid H2SO4, we get at 35 degrees centigrade, we get nitrobenzene. But whenever we treat it, same reagent, nitric acid H2SO4, at 100 degrees centigrade, we get metadinitrobenzene, NO2, NO2. So here you can see the temperature is a factor. The reagent is the same, nitric acid H2SO4, nitric acid H2SO4, the temperature is the factor. We know with increasing temperature, generally the rate of reaction will increases. So what is shown from here, this nitrobenzene is less reactive compared to benzene towards the aromatic electrophilic substitution. So aromatic electrophilic substitution means, in general, an electrophile is substituted to a aromatic nucleus by replacing H plus atom. E plus means they have the density of electron, they have the less dense electron. That means they are electron deficient elements or ions. So whenever they will react with aromatic nucleus, that aromatic nucleus must have to more electron to facilitate to accelerate the reaction. So if you consider nitrobenzene and benzene, what is the difference? Here nitrobenzene is present. We know nitrobenzene is showing minus I effect, that will attract the electron towards itself. That means the electron density on the benzene nucleus become smaller, reduces. The electron density of the benzene nucleus will reduces due to the presence of this nitro group, which is showing minus I effect. But in benzene there is no extra effect, no plus I, no minus I, nothing. So if you consider the electron density in particular this nucleus, say X, and electron density particular to this nucleus, say Y, we can say that Y is always greater than X. So where is the electron density is much more? In benzene compared to nitrobenzene. So which will react faster? The electron dense compound will react faster compared to in aromatic electrophilic substitution. It is almost clear from temperature. When benzene is react with to form nitrobenzene, the temperature requires 35 degrees centigrade. But when nitrobenzene react to form metadinitrobenzene, then temperature require 100 degrees centigrade. So nitrobenzene is less reactive towards benzene in aromatic electrophilic substitution reactions. So this can be easily explained with the help of minus I effect. These are the few applications, but there are lots of applications when you go through the another video in next class or in future. It can plus I and minus I effect, resonance effect, electromagnetic effect, hyperconjugative effect. That are the basic things of organic chemistry that will very much helpful for us to understand to understand the reaction mechanism and a reaction in details. So you can focus it with great concentrations. So third one is, first one is physical properties, second one is chemical property. First chemical property is chemical reactivity. Now third one is acidic strength. Acidic strength of acids. So acidic strength, that means say we have 3 or 4 types, A, B, C, D, 4 acids. So how can you determine the relative order of the acidity of these 4 acids? So this effect, these observations or these results can be explained easily with the help of plus I effect. For example, say acidic. First I am going to clear what is acidic. Acids, there are lots of definitions about the acid and bases. The first one is, that is very earlier scientist Arrhenius, who proposed first what is acid, what is base. And acid is a substance which can donate electron pair. An acid is a substance which can H plus ion in aqueous solution, and the base is a substance which can donate hydroxyl ion or OH minus in aqueous solution. So say an acid can be written as HA. So if you consider, and according to the Arrhenius theory, Ha will remove or release H plus and it will form A minus ion. And this A minus ion is responsible for the acidity of this acid. All of you know, I think, last Sethiler principle. If you consider this is an equilibrium reactions. So equilibrium will move towards the right side. When the equilibrium move towards the right side, the percentage of H plus will increases. That means the acidity of the molecule is increases. So what is the driving force behind it? If we somehow increase the stability of A minus, which is also called the conjugate base of acid. If you somehow increase the stability of this conjugate base of the acid, the equilibrium will shift it towards the right side. That means the percentage of H plus ion will increases. Percentage of H plus ion increases means the acidity will increases. So in general, we can say that the compounds, if you consider the different types of compounds in acidic about their acidic strength, we can say that higher the stability of the conjugate base, higher is the acidity. The molecules, all the acids molecules have conjugate base, and the higher is the stability of the conjugate base, higher is the acidity. Now, what is the conjugate base? Just you release one H plus from an acid. After releasing one H plus from acid, whatever you get, that will be the conjugate base. For example, you can say, I am giving some examples. HCl, for HCl, conjugate base is Cl minus. For nitric acid, conjugate base is NO3 minus. For acetic acid, conjugate base is CH3 COO minus. Just I am removing one H plus, one H plus, one H plus. That. As simple as that. So don't worry. Just listen the class carefully and try to understand. Now I am giving some examples which will be clear for you. So who are taking the class, who are watching this video as a first, I can say that this is my first organic class video, and I am especially in organic chemistry, and basically I am focused on organic chemistry. Sometimes I will also make some video about inorganic chemistry and physical chemistry. That will come in not infrequent, but in much more video will be concentrated on organic chemistry. Now take some examples. Acetic acid, CH3COOH, Cl CH2COOH, Cl Br CH2COOH. Suppose let us take 3 examples. What is this compound? This is acetic acid. This is chloroacetic acid. This is bromoacetic acid. What is the difference? You can see that this acid group is fixed. COOH, this is fixed. So what is the difference is coming? We can write this CH3 as CH2H. Here H is replaced by Cl, and here H is replaced by Br. This is called alpha bromoacidic acid. This is called alpha chloroacidic acid. This is called acetic acid. So we move from left to right. The literature value says that acidity will increases. So how can you explain it? You can see the difference. HCl-Br. You can easily explain it by minus I effect. Sorry, we have some mistakes. Just I am correcting it. Br will be Cl. Now it is okay. This is bromoacidic acid. Bromoacetic acid. This is chloroacetic acid. So you can clearly see that hydrogen is replaced in second compound. Hydrogen is replaced by Br. In third compound, hydrogen is replaced by chlorine. So if you know the electronegativity of these three atoms, the picture will be clear. Chlorine is more electronegative than bromine and hydrogen. So electronegativity greater means their minus I effect is very much strong. That means the conjugate base from this acidic acid, just to remove this acidic proton, you will get CH3 COO minus. And if you get from bromoacidic acid, the conjugate base is CH2Br COO minus. And the conjugate base from chloroacidic acid is this one. So when move from left to right, you can see that here is chlorine, here is bromine, here is hydrogen. So minus I effect is very much stronger here than bromo, than hydrogen. So with increasing minus I effect, the stability of the conjugate base will increases from left to right. With increasing minus I effect, the stability of the conjugate base which also increases. That means the acidity will increases. So whatever we have conclude here, you can say in one line that with increasing minus I effect, generally the acidity will increases. Why? With increasing minus I effect, if you increase the minus I effect, the stability of the conjugate base of the corresponding acid will increases. You can question why increases? The conjugate base of an acid is an anion. You know, the conjugate base of an acid is an anion. How anion will stabilize? Anion will stabilize by reducing its electron density. How can you reduce it? If you put an electron withdrawing group towards itself, around it, or around it, it will attract the electron from the anions, and the resultant electron density of the conjugate base will reduces. That means the stability of the conjugate base will increase. So higher is the stability of the conjugate base, higher is the acidity. So how easily you can explain? Just see examples. Another examples. These are very simple. I am discussing some simple examples. Just I am showing how can you apply Plaza effect. That's why I am getting some simple examples. Cl, CH2, COH, Cl, Cl, CH, COH, Cl, 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 COH. You can see here in alpha position 1 chlorine, alpha position 2 Cl atom, in alpha position 3 Cl atom. So here minus I is very strong in trichloroacetic acid. That means the conjugate base of trichloroacetic acid is more stable compared to dichloroacetic acid and compared to monochloroacetic acid. So as simple as that, whenever you move from left to right, acidity will increases. So these are some few examples by which you can explain the acidity of the acid by using plus I effect. Now we are moving to another types of molecules, that is base. The basicity of the base is also explained with the help of plus I and minus I effect. Now I am moving to basicity. What is base? There are different types of definitions. Whenever I will take an acid base class, that will be helpful also for you, and it will be clear for you what is acid, what is base, what is the different type of definition of acid, why we develop the definitions of different times and different by the different scientists, that will discuss in some another classes. Now whatever we need, that particular part I will say you. Basicity. What is base? And the base is a compound which can abstract H plus ions. That is one example. And base is a compound which can donate electron. That is the basic definition of the base. The base is a compound which can donate electron. This concept is also known as Lewis concept. So higher the tendency of a molecules, higher the tendency of a compounds to donate the electron pairs, towards any electron deficient atom, higher is the basicity. So it will depends on how the molecules or the atoms will release the electron, will donate the electron. So higher is the donation property, higher is the basicity. For example, you can say that methylamine and ethylamine. We know ethylamine is more stronger base than that of ethylamine, because methyl group has C2H5 group has stronger plus I effect than methyl group. Plus I effect means it will increases the electron density on the atoms. Which atom? Nitrogen atom. This nitrogen atom is responsible for the basicity of this type of compound. That means amines, they may be aliphatic or aromatic, doesn't matter. The density of the electron, which electron? This lone pair of electrons will make this amine basicity. So higher is the density, higher is the basicity. So which character of the groups will increase the density of electron? The plus I effect, that both are showing plus I effect. So in another sense you can say that minus I effect will reduces the basicity of the compounds. If plus I effect will increase the electron density, minus I effect will reduces the electron density. For examples, another example you can say aniline, NH2, and CH3 NH2. So the basicity order will be, it is very simple. Just this is first class, I am discussing some simple examples, and when we move to the another class in later class, I will be discussing typical examples. which are helpful for your future and for your competitive exams. You have to clear basic things always. In for every subject, you have to clear basic things. If you clear your basic things, then everything will be clear for you. Whatever you learn, that will be crystal clear for you if you have basic things clear. So I am focusing myself to clear the basic things. Whatever I am taught today, that are mainly basic thing, that is plus I effect. Only plus I effect. I am focusing only to the plus I effect. So if you see here, methyl group has plus I effect, but there is in aniline there is no groups which can show this type of effect. So the electron density of this nitrogen atom will be much more than that of this nitrogen atom. So what is the effect that will play the role? That is the effect. Which effect? Plus I effect of methyl group. So with increasing plus I effect, the electron density on amino groups or any other basic group on a basic compounds will increase. So in generally whatever you can conclude, that I am writing in one line for acid and bases. With increasing minus I effect group in a molecules or in a compounds, the acidity of the corresponding compound will increases. And in another point we can say, with increasing plus I effect groups in a molecules in a compounds, the basicity of the corresponding compounds will increases. That is the bottom line of acidity, basicity, that is plus I and minus I effect. I am not saying that another effect can't explain acidity and basicity. This is I am showing only. Today's class I am focused only in plus I effect. I am going to summarize this effect in shortly. So whatever we have learned today, I am going to summarize easily. The heading of my class was the electron displacement in a molecules. Molecules means mainly in covalent molecules. In covalent molecules, basically we can see whatever we have, only sigma bond and pi bond. So how this electron transfer, how this electron displays from one place to another, that depends on several factors. We are listed 4 factors which are very much responsible for this electron displacement behavior of the molecules. Those are inductive effect, electromagnetic effect, resonance effect, and hyperconjugative effect. Today's class I have only choose one type, that is inductive effect. What is inductive effect? If we consider a homonuclear diatomic molecule such as AB, AB means A is one atom and B is another atom. That means different atoms have different electronegativity. If you suppose B is more electronegative, so the bonding electrons will shifted towards B. That is, B becomes delta negative charge and A becomes delta positive charge. So the atoms which withdraw the electron pairs towards itself, that is showing minus I effect. You can easily remember electron withdrawing towards itself means that groups or atom is showing minus I effect, because one delta negative charge is placed over it, and another atoms which is pushing the electron towards delta negative center, that is showing plus I effect. You can remember it easily, just like a story. So which group will show plus I effect? The group which have more electron density. The group which have more electron density, that will show plus I effect. So easily you can think about that. इलेक्ट्रॉन डेंसिटी बेसिक मतलब ज़्यादा कहाँ है, इलेक्ट्रॉन डेंसिटी ज़्यादा कहाँ है, it will be more in anions. Anions are very much electron dense radicals. So जितना anions रहेगा, जितना anions आपके पास है, अवेलेबल है, आप लोग जानते हैं, सब anion के पास क्या रहेगा, कौन सा इफेक्ट रहेगा, माइनस आई इफेक्ट, सॉरी plus I effect. The anions are electron dense compound, that is they will push the electron, they are showing the plus I effect. And the elements which are positively charged means one center is positive, that means electron deficient center, they are showing minus I effect. I have discussed in details, and their applications also in some physical and chemical properties. For example, the dipole moment. I am taking the examples of cis-2 butene and trans-2 butene, and also some chemical properties like chemical reactivity, their chemical reactivity, acidity, basicity, etc., etc. So today's class is only for those students who are for English medium schools, who are learning in English medium school. They don't know about the Bengali or Hindi. I think some students know Hindi also, English also, little bit Bengali also in India, or basically in West Bengal. I am from West Bengal. I thought that I'll take this class in Bengali also, in English also, in Hindi also, or in mixed language. Whatever I have done in future, I'll think about that, which combination will be better for you. Your feedback is very much important for me. Give your feedback, make your comments, that will helpful for me, and that will make to serve better for you. That will and that will give some energy to serve you in details, in modern fashions. In future, I will plan to take some smart classroom, to organize my room as a smart classroom. That will be very much helpful for you, and that will what is the important behind it? That will save your times. I am writing in whiteboard, that will taking some time. If I present there, if I present some questions, I have to write the questions. That will take time. That will be very much I think a time consuming process. So in next or in future, we will see in video classes which will be in ICT enabled classroom. So I am going to end today's class. Lots of thanks to all of you who are watching my videos, who are subscribing my videos, who are giving some their valuable comments, especially for my students who are interestingly watching these videos. They are making some comments also. The good may bad doesn't matter, but your comment is important for me to improve myself in to better positions, to serve you better video. If you like this video, please comment, share or subscribe, or give some suggestion or feedback. Thank you very much for your kind cooperation and for your kind I think for your kind cooperations and for your kind patience. Thank you very much. Best of luck for your future. And if you missed the previous video, that was in Bengali. If you want to learn in English, I will make some video in English also. That videos was basically on VC pair theory, and the one part of the VC pair theory, which is the which is the determination of the structure of molecules by using VC pair theory. If anybody have any suggestion that sir please make some video in English of VC pair theory, I'll also make for you if you make some comments or if you give some suggestion. Thank you everyone. Goodbye. Bye bye. See you in next class. Thank you very much.